something has awakened in the dark. No one was supposed to be watching that part of the sky. It was routine monitoring, the kind of nightly data sweep that astronomers let run while they sleep. But sometime between midnight and 3 a.m, UTC, a faint smudge catalogued as 3I, Atlas began to glow. Not gradually, not the slow rise you'd expect from a comet, gently warming as it drifts inward. It brightened suddenly, like someone had flicked on a light in deep space. At first, the numbers looked wrong. Observatory software flagged the anomaly. Magnitude negative 0.2 increase, then another negative 0.6 within an hour. Automated filters marked it as a possible transient, a glitch. But the glitch didn't go away. By sunrise, 3 different telescopes in Hawaii, Chile, and South Africa had reported the same thing. 3I Atlas was brightening at a rate no comet had ever shown this far from the Sunday. For context, comets are like embers. They flare up slowly as sunlight heats their ices, vaporizing trapped gases into long, streaming tails. This one was still far beyond Mars's orbit, over 3 astronomical units away, where sunlight is weak, where everything sleeps. Yet, the coma surrounding 3I Atlas had doubled in luminosity overnight. Its dust halo expanded, spectral lines sharpened. It wasn't drifting anymore, it was reacting. Astronomers across the globe scrambled to confirm. By the time Japan's Subaru telescope turned its instruments toward the coordinates, the brightness had increased again, nearly a full magnitude higher than any model predicted for the next 3 months. That shouldn't be possible. Not from a comet still so cold, it should have been dormant. Something inside it had woken up. And as if on cue, the sun, our own restless star, stirred too. Before we continue, I have something extraordinary to share with you. For nearly 3 decades, I've devoted my life to showing that the universe isn't just something to gaze upon, it's something you can truly understand. And once you begin to see those patterns, the world never looks the same again. That's why I've created something special, a new experience called Cosmic Calm. Inside the Cosmic Calm Academy, I'll take you step by step through the science that shapes reality itself, from the birth of stars to the laws that govern your own existence. My 28 years of discovery and understanding all distilled into one place. For less than the cost of a lunch, just $50 a month, you can begin the journey to think like a physicist and learn directly from me. Join me inside the Cosmic Calm Academy today. The link is in the description and pinned comment below. Solar cycle 25 had been ramping quietly for years, but in late October, it crossed a threshold unseen in decades. A sunspot cluster spanning more than 200,000 kilometers cracked across the photosphere, unleashing an X9 class flare, the strongest since 2003's Halloween storms. The eruption hurled a coronal mass ejection directly into the heliosphere, a tsunami of plasma racing outward at over 1,000 kilometers per second. Most comets shrug off solar tantrums. They're small, distant, too cold for solar weather to reach in full. But 3I Atlas wasn't a normal comet. The timing was uncanny. Within hours of the CME's release, the comet's light curve shifted again, not just brighter, but pulsing. Minor variations every 42 minutes, like a heartbeat buried in the data. Researchers initially dismissed it as instrumental noise or atmospheric distortion. Then the same rhythm appeared in independent observations from space-based telescopes. Identical intervals, identical amplitude. That's when the whisper started. It's acting alive. To understand why this was so unsettling, you have to remember what 3I Atlas is, or rather, what it isn't. This isn't one of ours. It's interstellar, A visitor from beyond our sun's domain, forged under alien skies, carrying chemistry shaped by another star's hand. Every molecule inside it, every grain of dust, carries a record of a system that predates our own. When it first appeared in early 2025, it was already breaking rules, venting water where no comet should, spitting out nickel without iron, cyanide ratios that made no chemical sense. And now, months later, it's doing something even stranger, responding to solar activity as if it can feel it. The early brightness alerts triggered what's known as a global coordination event. It's a rare moment when observatories across continents set aside competing projects and focus on a single target. Data from the European Southern Observatory poured in alongside infrared scans from NASA's James Webb Space Telescope. Together, they painted a picture that only deepened the mystery. The comet's coma, that ghostly envelope of gas and dust, wasn't just reflecting sunlight. It was generating light. Specific emission lines, normally faint, were now blazing. Hydroxyl, carbon dioxide, trace organics. But the ratios were all wrong. It looked like chemistry caught in the act of changing, reacting to something invisible. A team from Caltech proposed an unsettling idea. What if the CMEs, charged particles, had reached the comet's magnetized shell-inducing currents deep within? If the comet's core still contained conductive minerals or trapped volatiles, those sudden electrical discharges could have triggered sublimation from within, igniting pockets of buried ice. Essentially, the comet could be electrically breathing, a phenomenon no one had ever documented. Meanwhile, deep space weather monitors confirmed the sun's outburst had bent the entire heliosphere slightly outward. Cosmic rays surged. Auroras erupted across Earth's poles in colors not seen in years, crimson curtains streaking as far south as Texas and northern Italy. And far beyond the planets, Three-Eye Atlas seemed to shimmer in sympathy. For astronomers who study interstellar visitors, this was more than coincidence. When the data hit public repositories, amateur astronomers joined in, submitting their own light curves from backyard telescopes. Within 48 hours, a clear trend emerged. The brightening wasn't uniform. It appeared to rotate waves of luminosity, sweeping across the comet's surface every few hours, as if it had active regions, like sunspots. But comets don't have sunspots. They don't have magnetic fields strong enough to anchor plasma, unless something inside was conducting electricity. One researcher described it bluntly: it's behaving like a battery in a storm. And that idea, as wild as it sounds, started to catch traction. If the comet was interacting electromagnetically with the solar wind, it could explain the rhythm, the pulses, even the unpredictable surges of brightness. It might also explain why the composition of its tail was shifting, cyanide decreasing, carbon dioxide rising, like chemical layers being peeled away one by one. Each flare of the sun might be literally excavating the comet's history, but the numbers didn't fit. The energy required to vaporize that much material exceeded what even a CME's impact could deliver, unless the energy wasn't coming from outside, unless it was coming from within. That's when a new model appeared, one that few dared to publish publicly. The data suggested a core temperature higher than any known comet nucleus. Internal heat sources? Radioactive decay? Unlikely. A residual pocket of primordial energy? Impossible, unless the comet was once part of something larger. A fragment, maybe, from a protoplanet torn apart billions of years ago, still carrying trapped energy in its depths. If that were true, Three-Eye Atlas wasn't just a comet, it was a survivor. By the end of that first week, the world had taken notice. News outlets splashed headlines: alien comet defies physics, 3I Atlas brightens mysteriously amid solar chaos. Astronomers baffled by sudden flare beyond Mars, but beneath the headlines, quiet unease spread, because this wasn't supposed to happen naturally. And the timing, the coincidence with the most violent solar outburst in decades, made it impossible to ignore the question forming in every researcher's mind. Was the sun's fury waking the comet? Or was the comet's awakening provoking the sun? Across observatories, instruments hummed, telescopes locked in, radio antennas tilted upward. Every second, the comet's light was growing, shifting, pulsing, like a distant heartbeat synced to the star that birthed our world. No one could say for sure what was happening inside that frozen traveler from another sun, but one thing was clear: something had awakened in the dark. They thought the breathing had stopped. Months ago, when Swift first caught 3I Atlas exhaling water into the void 40 kilograms every second, astronomers were stunned. At a distance where comets sleep, it had been alive. Then the flow waned, data flattened, and the consensus formed. Whatever strange chemistry drove that early venting had ended. The visitor was drifting again into quiet until now. The same telescopes that recorded the new flare turned back to their ultraviolet filters, and the numbers made even seasoned researchers swear out loud. Hydroxyl emission, the signature of sunlight tearing water molecules apart, was back and 10 times stronger than before. 3I Atlas wasn't just brightening, it was breathing again, harder, faster, as if something deep inside had reawakened and couldn't stop. When Swift's archived data from January 2025 were re-examined alongside the latest readings, the trend became unmistakable. The water production wasn't linear, it oscillated. Spikes followed by sudden lulls, like an exhale, a pause, then another. The cadence eerily mirrored the new light pulses astronomers had detected after the solar storm. The implication was unnerving. 3I Atlas seemed to be synchronizing its breaths with the sun's rhythm. Every time a burst of solar wind brushed through its region of space, the comet's outgassing spiked. But the response came too quickly to be explained by sunlight alone. Even at the speed of light, radiation pressure shouldn't heat subsurface ice so fast, especially through layers of insulating dust. There had to be another mechanism, a trigger, operating inside the comet itself. The European Space Agency's infrared observatory, Herschel 2, positioned well beyond Earth's magnetosphere, captured something that might explain it. Thermal signatures showed localized hot zones scattered across the nucleus, temperatures surging by dozens of degrees in mere minutes, then fading. It looked like flash boiling patches of ice suddenly vaporizing from beneath the crust, but the pattern didn't fit random fractures. The hotspots migrated, they seemed to move. A working theory emerged. Pockets of volatile compounds trapped under the surface, ammonia, methanol, maybe exotic ices unknown in our solar system, were undergoing chain reactions. When the solar winds charged, particles struck the comet's induced magnetic sheath, electric currents rippled through its body, igniting these volatile reservoirs in sequence. One astronomer compared it to a frozen lung, inflating and deflating under invisible pressure. Another simply called it breathing lightning, yet not everyone agreed. At Caltech, a group specializing in cryogenic chemistry proposed a more subtle cause. They suggested that 3I Atlas's brightening wasn't driven by heat at all, but by chemical recombination. In extreme cold, some molecular bonds remain partially broken, storing energy that can be released when the structure changes, a kind of slow fuse left over from its birth. When the comet absorbed even a whisper of solar radiation, those metastable bonds could recombine explosively, releasing bursts of energy from within. That would explain the irregular pulses and the intense water vapor without requiring deep heating. But even that didn't match the numbers. The total energy output calculated from the observed water vapor exceeded what the recombination model allowed. Something else was feeding it. Meanwhile, the shape of the coma, the diffuse shroud of gas and dust, began to distort. High-resolution imagery from Webb showed jets of vapor spiraling outward, forming filaments that twisted like strands of DNA. Each jet appeared to originate from specific coordinates on the surface, tracing arcs that repeated every 11 hours. If 3 I Atlas were merely rotating, those jets should form a predictable corkscrew pattern. Instead, they bent irregularly, as if magnetic fields were guiding them. In a simulation run at the University of Helsinki, plasma physicists modeled the comet as a semiconductive core wrapped in ionized gas. When exposed to fluctuating solar wind, the model reproduced the same twisting plumes seen in the data. It was an elegant solution, except for one problem: no comet should be that conductive. To carry currents on that scale, its interior would need metallic veins or an organized structure, not a random rubble pile of ice and dust. Unless, once again, it wasn't made like any comet we've ever known. By the second week of observations, the outgassing had become so intense that the coma's diameter surpassed that of Jupiter. From Earth's perspective, 3 I Atlas now glowed faintly in binoculars, a dim blue-white smear among the stars. Amateur astronomers began reporting subtle color shifts over hours, a sign that chemical composition in the vented gases was changing in real time. Spectroscopy confirmed it. Alongside the expected water and carbon dioxide, new lines appeared: ethane, acetylene, even traces of hydrogen cyanide increasing as the water peaks fell. The comet was evolving chemically before our eyes. It was as though it had multiple breathing modes, switching gases, the way living organisms switch metabolic states. In the control room of the Mauna Kea Observatory, one astrophysicist murmured, "We're watching alien geology perform biology." Still, the data remained stubbornly ambiguous. No definitive cause, no consensus. Was it solar energy, electrical discharge, or internal chemistry? The more instruments turned toward 3 I Atlas, the more complex it appeared. Then, during a long exposure observation, a new anomaly emerged. Deep within the glowing halo, faint pulses of infrared light flickered from a single region on the nucleus. They weren't random. The pattern repeated every few rotations: short, long, long, short. It didn't correspond to any known natural process. Most dismissed it as coincidence or interference, yet it added another thread to the growing sense that this comet wasn't merely reacting, it was performing. For scientists tracking the water data, though, one fact mattered most: the outflow rate was climbing exponentially. By late October, estimates placed it at nearly 300 kilograms of vapor per second, a torrent of ice becoming gas faster than any comet in recorded history. Even the mighty Hale-Bopp, seen blazing across Earth's skies in 1997, never exhaled this much so far from the Sunday. If the trend continued, 3 I Atlas would begin to disintegrate under its own fury. But it didn't. Instead, it stabilized, holding its brightness steady for days before another subtle pulse began. Like breathing, scientists started plotting the intervals against solar data. To everyone's disbelief, the comet inhales water, surges aligned perfectly with spikes in the sun's X-ray flux. Not days later, not hours, but within minutes. The distances involved made that impossible under normal physics. At 3 astronomical units, even light takes half an hour to arrive. Yet somehow, 3i Atlas was responding in near real time. No model could explain that. None. One team proposed an exotic idea rooted in magnetohydrodynamics. Perhaps flux ropes, magnetic tunnels extending from the sun, could be coupling the two directly, transmitting electrical changes faster than the solar wind itself. If so, 3i Atlas wasn't just being illuminated by the sun, it was connected to it. The thought sent a shiver through the community, because if that connection was real, it meant the comet could influence the sun as well, a feedback loop between a dying star fragment and our living star. As debates raged in conferences and data servers filled with terabytes of new readings, the public watched the sky. 3i Atlas, faint but visible, lingered near the constellation Perseus, a wandering light that seemed to flicker with intent. No one could yet say what was driving its breath: radiation, magnetism, chemistry, or something older and stranger, but every new flare whispered the same message written across the cosmos in vapor and light. The comet was alive again. And this time, it didn't seem like it planned to stop. No one saw the sun coming. For weeks, its face had been restless, peppered with sunspots, so large they dwarfed Earth several times over. Solar cycle 25 had been building like a drumbeat, but what came on October 29th shattered every forecast. At 1437 UTC, a magnetic filament stretched across the solar surface, twisting, tightening, then snapped. The eruption was titanic. An X-12 class flare, the strongest since the Halloween storms of 2003, exploded from the photosphere with the power of 1 billion hydrogen bombs. It hurled a coronal mass ejection, a continent-sized bubble of plasma and magnetic field, straight into the inner solar system. Within minutes, satellite telemetry lit up with alerts. Spacecraft around Earth went into safe mode. Radiation monitors spiked. The sun had unleashed a storm unlike anything this generation had seen. To most of the world, it was a spectacular but distant event. Auroras dancing at unusual latitudes, radio blackouts, satellites rebooting. But to astronomers already watching 3i Atlas, it felt personal, because the moment the flare erupted, the comet's light curve changed again. Not hours later, minutes. The synchronization was uncanny. Observatories from Chile to Australia reported the same pattern. 3i Atlas's brightness jumped by nearly 30% within half an hour of the flare. Long before the charged particles of the CME could physically reach it, something invisible, instantaneous, had touched the comet across hundreds of millions of kilometers. The question was how. Solar physicists flooded into the discussion, bringing the language of heliophysics into cometary science. They spoke of plasma induction, the process by which moving magnetic fields generate electric currents in conductive material. The sun's flare had twisted the interplanetary magnetic field like a whip. If 3i Atlas possessed even faint metallic veins or magnetized minerals, those sudden field changes could have induced colossal electric discharges beneath its crust. Imagine lightning not through air, but through ice and rock. In the hours following the flare, radio telescopes detected faint, low-frequency emissions emanating from the comet's direction, whispers in the 50 kilohertz range, right where plasma instabilities tend to sing. That same night, ground-based telescopes recorded a violent jet of gas erupting from its southern hemisphere, ejecting dust thousands of kilometers into space. The sequence lined up perfectly. Solar flare, electromagnetic pulse, electrical induction, eruption. It looked less like coincidence and more like cause and effect. To understand the scale, picture the sun's magnetic field as an ocean of invisible waves. When a CME erupts, it sends ripples racing outward, shock fronts, of ionized plasma carrying tangled lines of magnetism. Normally, those waves buffet planets and comets alike, but their impact fades with distance. Except in this case, something was amplifying the connection. NASA's Parker Solar Probe, orbiting close to the Sun, caught something unusual. The CME's magnetic structure, its flux rope, remained coherent far longer than expected. Its shape didn't diffuse, it stretched. Analysts realized it was behaving like a conduit, a rope of plasma maintaining contact between the Sun and interplanetary space, oscillating like a power line. If one end of that rope brushed three I-Atlas's induced magnetic field, even briefly, the result could be devastating or illuminating. Data from the comet's coma supported the idea. As the solar storm intensified, the ratio of ionized oxygen in the coma spiked dramatically. That could only happen if electrical currents were stripping electrons from water molecules at the source. In other words, the comet wasn't just boiling, it was being electrified. One heliophysicist described it in hauntingly simple terms. It's as though the sun reached out and touched it. The storm didn't relent. Over the next 48 hours, secondary flares rippled from neighboring sunspots, each feeding the growing magnetic tempest. Cosmic rays surged, streaming outward at nearly light speed, bombarding everything in their path. Interplanetary spacecraft recorded radiation levels high enough to fry unshielded electronics. And out there, far beyond Mars, 3I Atlas responded like a live wire. Its coma grew so luminous that photometers began to saturate. Spectrographs showed excited hydrogen lines shimmering where none existed days before. The dust tail elongated, curving away in a sudden, elegant arc evidence that charged particles were reshaping its path. But the most bizarre observation came from the Solar and Heliospheric Observatory. Its coronagraph, designed to block the sun's glare, caught something almost poetic: fine threads of plasma streaming from the comet toward the solar wind, as if the two were connected by luminous filaments. For a few hours, 3I Atlas appeared tethered to the sun by glowing strings. Then, abruptly, the link faded. The scientific community erupted with theories. Some said the comet's surface was rich in ferromagnetic dust, capable of carrying induced currents powerful enough to vaporize buried ices. Others argued that its internal composition, that strange nickel without iron, made it uniquely responsive to magnetic flux. Nickel compounds can sustain induced fields for long durations, effectively turning the comet into a short-lived dynamo. If true, that would explain why its brightness changes lagged solar events by mere minutes instead of hours. The comet wasn't passively reflecting light, it was part of the storm itself. Across the heliosphere, the effects cascaded. Planetary magnetospheres wobbled. Auroras bloomed. And for a brief window, the entire solar system felt electrically alive. It was as if every world, moon, and rock had been wired into a single circuit, and 3I Atlas was glowing brightest of all. In a late-night press conference, Dr. Noura Al-Khatib of the European Space Agency summarized what many had begun to suspect. We are witnessing the Sun and an interstellar object engaging in an electromagnetic dialogue. One speaks in plasma, the other replies in light. Skeptics, of course, pushed back. They pointed out that correlation is not causation. The comet could have been brightening on its own, the flare's timing might simply be coincidence, but the probability of repeated coincidences was shrinking fast. Each solar outburst produced a corresponding pulse in the comet's light curve. As the data poured in, heliophysicists began modeling the event on supercomputers, simulating magnetic reconnection on scales measured in astronomical units. The models predicted something chilling. If the induced currents continued to rise, the comet's crust could fracture completely, exposing its volatile heart. A self-amplifying loop, solar flare triggers discharge, discharge releases gas, gas increases conductivity, which triggers more discharges, could end in detonation. Yet, instead of disintegrating, 3I Atlas stabilized again. The light evened out, the breathing slowed. It was as though the storm had energized it to the brink of destruction, and then somehow it adapted. By the end of that week, the CME's shockwave finally reached the outer planets, a diffuse ripple of charged particles drifting past Jupiter and beyond. The solar system quieted. On Earth, auroras faded back to the poles. Satellites resumed normal operations. But the comet remained changed. Its coma still glowed faintly blue, an afterimage of the storm. Instruments detected residual magnetism around it, a ghost field that refused to dissipate. That magnetic cocoon shouldn't exist, yet it persisted, as if the comet had learned the sun's frequency and decided to keep it. For the first time, some researchers began to describe 3I Atlas not as an interstellar wanderer, but as an interstellar capacitor, an object capable of storing and releasing electromagnetic energy across cosmic distances. If that was true, then every solar flare was not merely illuminating it, but charging it. And when the next eruption came, and it would, the comet might answer with something no one had seen before. The sun had roared, the comet had replied, and somewhere between them, the silence of space had started to hum. At first, it looked like noise background scatter in the data. But by the second night, no one was calling it that anymore. Spectroscopy is astronomy's truth serum. It doesn't care about illusions or hype. It simply tells you what's there. Split light through a prism, and every element sings its own tune, a barcode of the cosmos. Hydrogen hums in crimson. Oxygen glows green. Nickel, cobalt, iron all leave their marks in fine, distinct lines. It's how we know what stars are made of, how hot they burn, even how fast they're moving. But when telescopes turned toward 3I Atlas in the aftermath of the solar storm, the music didn't make sense. Across observatories in Chile, Hawaii, and Spain, identical anomalies appeared. Oxygen emission lines, bright, sharp, impossible. There shouldn't have been any. Not out there. Not yet. At that distance from the sun, oxygen should remain locked inside ice, bound to hydrogen as H2O, or trapped in frozen CO2. Only when sunlight or electrical discharges split those molecules apart do free oxygen lines appear. But the sheer strength of the oxygen signal implied something else entirely, an internal source. As though the comet were manufacturing oxygen deep within itself. Researchers checked and rechecked the data, thinking perhaps it was contamination, maybe a reflection from Earth's own atmosphere. It wasn't. The spectral shifts matched the comet's motion perfectly. The oxygen was coming from inside 3I Atlas. Then the cyanide ratios began to change. Weeks earlier, astronomers had already detected hydrogen cyanide and its simpler cousin, CN, streaming from the comet's coma. The ratios were odd, even then too high for the levels of other volatiles, suggesting unique chemistry. But now, those ratios were swinging wildly, doubling or halving between nights. That shouldn't happen unless the comet's composition itself was evolving, molecule by molecule. Spectrographs recorded fresh signatures each time the comet breathed. When its light pulse brightened, CN emissions surged. When it dimmed, CN fell, replaced by lines from acetylene, methane, and something stranger, faint signatures of formamide, a prebiotic compound rarely found outside controlled laboratory conditions. To the scientists watching, it felt like the comet was mixing its own chemistry in real time. Still, that wasn't what broke the quiet hum of confidence in the scientific community. What did was the nickel. Once again, the metal showed up blazing bright in every data set, and once again, iron was missing. The ratio was so skewed, it bordered on absurd. Pure nickel emission lines with trace cobalt, no detectable iron at all. It was like catching smoke without fire or thunder with no lightning. In known cometary science, this is forbidden. Iron and nickel form together in stellar furnaces, fused in the hearts of supernovae, their cosmic siblings. Their sublimation temperatures differ by mere tens of degrees. You see one, you see both, always. Except, apparently, when the comet comes from somewhere else. One late night session at the European Southern Observatory revealed an even deeper oddity. The nickel lines weren't matching terrestrial isotopic ratios. The peaks were slightly offset, subtle, but measurable, suggesting isotopes of nickel not dominant in our solar neighborhood. Nickel 5-8, nickel 6-0, and something faint at nickel 62 inches, proportions no model predicted. That single result sent ripples through every lab involved, because isotope ratios are fingerprints, cosmic DNA. They tell you where an element was forged, and these fingerprints didn't match anything in our corner of the Milky Way. It was as though 3I Atlas had been born from the ashes of a different kind of star, one that cooked its metals under different pressures, different lifespans, maybe even a different kind of supernova entirely. But there was more. High-resolution spectra from the James Webb Space Telescope caught faint lines that shouldn't exist at all. Deuterium compounds heavy water far above normal abundance, and something else buried in the noise. An isotope resembling oxygen 1-8 at levels no comet from our system has ever shown. That oxygen signature was what gave the comet its surreal blue-white glow, the same eerie radiance that now stretched across millions of kilometers. In the data logs, one researcher simply typed, "Impossible, check calibration." They checked, calibration was fine, the readings held. Slowly, the emerging picture of 3I Atlas began to feel less like a natural object and more like a relic, a fragment from a galaxy older and more exotic than ours. The patterns in its spectrum whispered of heavy element synthesis gone slightly wrong, or perhaps gone right in a place where physics took a different turn. Dr. Serena Kim at Caltech put it bluntly in an early preprint: "We are staring at matter forged under a stellar recipe we've never encountered. Its chemistry is not alien in form, but alien in memory." The implications were dizzying. If its isotope ratios didn't match local stars, then 3I Atlas wasn't just interstellar, it was intergalactic. A traveler not from another solar system, but possibly another generation of the universe's evolution. Meanwhile, the spectral anomalies deepened. A faint line appeared one evening around 589 nanometers, near sodium's natural glow, but slightly shifted, as if doped with something heavier. A false sodium, echoing real elements, but belonging to none. Astronomers began cataloguing these mystery lines, one by one. 612 nanometers, 733 nanometers, 845 nanometers. Each corresponded to transitions no known element or molecule could produce. Some speculated these were complex organometallic compounds, hybrids of nickel, carbon, and nitrogen, forged in environments of extreme cold and radiation. Others suggested they might be quantum effects, isotopic fine structure caused by hypermagnetic fields within the comet's core. Whatever the cause, every new line told the same story. The rules were bending. It wasn't just the presence of foreign chemistry, it was the rhythm. The comet's emissions shifted nightly, sometimes hourly, as though its internal processes were dynamic, responding to the solar environment like an organism reacting to stimuli. During one coordinated observation run, multiple telescopes captured a synchronized event. 3I Atlas dimmed briefly, then flared, and in that instant, new spectral lines appeared, unknown, transient, then gone. When plotted on a timeline, the frequency pattern resembled harmonic oscillations, as if the comet had resonated. Could a rock resonate? The data suggested yes. The comet's coma pulsed in step with electromagnetic activity streaming from the sun, faint, rhythmic modulations every 160 minutes. It looked disturbingly like a feedback loop. Solar plasma stimulates cometary emission. Cometary ions reinforce magnetic flux, which in turn stimulates new emissions. A self-sustaining conversation of light and charge. Then came the kicker. In a follow-up analysis, scientists compared 3I Atlas's nickel line intensities to known stellar catalogues, supernova remnants, neutron stars, even white dwarfs. One match stood out. A Type 2b supernova remnant catalogued 700 light-years away, long cold now, but still leaving a trace of similar isotope ratios. 94% correlation. That number shouldn't exist, yet it did. If those fingerprints matched, it meant the comet might have been born from the debris of that ancient explosion matter, ejected before our sun even formed, frozen in interstellar drift for billions of years, until gravity finally lured it into our system. Every atom of 3I Atlas, every flicker of light in its ghostly tail could be a time capsule older than the planets themselves. By the time the news reached the public, speculation had already outrun science. Theories of alien probes and ancient technology flooded the internet. Scientists tried to anchor the narrative in data, but the truth was stranger than fiction anyway. The comet was defying known chemistry not because it was built, but because it was born differently. Still, one question lingered. If the sun's storm had triggered these emissions, and the comet was now stabilizing, what would happen the next time the sun roared? Would the anomalies intensify or evolve into something new entirely? The answer would come soon enough. Because as astronomers continued recording, a new phenomenon began to appear at the edges of the data, faint distortions in the comet's surrounding plasma, ripples that looked suspiciously magnetic. The light was strange, the chemistry was stranger. But the magnetic field that was about to change everything, it began as a glitch. At least, that's what Mission Control at the Solar and Heliospheric Observatory thought when their magnetometer data started spiking. Faint, rhythmic, and impossible. A comet, especially one so far from the sun, shouldn't have a measurable magnetic field at all. They're dirty snowballs, not dynamos. They reflect light, they don't shape it. Yet as 3I Atlas continued its erratic, brightening sensors across multiple spacecraft, began to whisper the same strange signature, a pulse. The field wasn't random. It had structure, an envelope that expanded and contracted around the comet like a slow heartbeat. At first, researchers assumed it was an illusion caused by the sun's violent outbursts. After all, solar cycle 25 had reached its most volatile phase in decades. Coronal mass ejections were flooding the heliosphere with charged particles, bending and twisting magnetic field lines into turbulent rivers of plasma. Any small object caught in that stream could easily register false readings. But the numbers didn't fit. Solar magnetic fields fluctuate chaotically, noisy, entropic. What 3I Atlas produced was organized, repeating every 3.8 hours. The amplitude rose and fell in precise ratios, as if governed by an internal clock. One data analyst at NASA's Goddard Space Flight Center noticed something even stranger. When they overlaid the field pattern on the comet's photometric light curve, the peaks aligned perfectly. Each time the comet flared in brightness, the magnetic intensity spiked a few seconds later. The timing was too exact to be coincidence. It's as if something inside is generating it, one engineer murmured during the review meeting. The phrase caught on. Within days, the entire scientific community was using it half as metaphor, half as warning. The first deep field magnetic mapping came from ESA's solar orbiter, which caught 3I Atlas glancing along the edge of its sensor range. The data revealed a lopsided magnetic sheath, not a smooth dipole like Earth's, but a twisted, asymmetric field curling around the nucleus. Its northern flux was oddly concentrated, creating a halo where charged dust particles spiraled into coherent vortices. In short, the comet had grown a magnetosphere. The finding was so absurd that several teams ran independent simulations to disprove it. Yet each attempt, no matter the variables, reproduced the same conclusion. The field could not be accounted for by solar induction alone. Something inside the comet was interacting with plasma in a way no natural icy body should. The theories came fast. Hypothesis 1. Induced magnetism. Perhaps metallic inclusions, nickel, cobalt, or some exotic alloy were forming conductive pathways through the nucleus. As solar wind ions bombarded the surface, they might induce transient electric currents, generating a weak magnetic bubble. But the field strength, measured at nearly 30 nanoteslas, several times greater than expected, argued against that. Even a solid core of metal wouldn't produce such coherence unless it was rotating. Hypothesis 2, internal dynamo. Could the comet harbor a molten or semi-liquid interior layer churning like the metallic core of a planet? Unthinkable for a body so small unless there was another energy source. Perhaps radioactive decay from trapped isotopes or tidal flexing from gravitational interactions. But 3I Atlas was too isolated for that. Hypothesis 3, plasma feedback. The comet's earlier breathing of water vapor and volatiles might have built a dense iron cloud. When solar particles collided with that cloud, they could generate self-sustaining electromagnetic loops, a miniature aurora system around the nucleus. In that case, 3I Atlas wasn't just reacting to the sun, it was talking back. The plasma sheath theory gained traction after several spacecraft recorded ion densities surrounding the comet far higher than any known analog. The region around it wasn't empty space, it was a living fog of charged particles, rippling and rearranging itself in response to solar gusts. In radio frequencies, the comet even began to emit faint bursts, static bursts, at 21 megahertz, recurring at near-perfect intervals. To the untrained ear, it sounded like the hiss of interference. To others, it sounded disturbingly rhythmic. At the Mauna Kea Observatory, Dr. Alejandro Ruiz stared at the magnetogram overlays until dawn, muttering to himself. "The pattern repeats," he said to no one, "but not identically. It drifts like modulation." The drift was subtle, a slow shift in phase every few hours, enough to suggest the field wasn't fixed but precessing. In physical terms, that meant the source was rotating, like a magnetic gyroscope buried beneath layers of ice and dust. If that were true, then 3I Atlas wasn't just carrying a magnetic field, it was controlling it. The comet's tail began to behave differently as well. Normally, solar wind pressure pushes a comet's tail straight outward from the Sunday. But 3I Atlas's tail twisted against that direction, curving inward as though guided by invisible hands. Plasma filaments snaked around it in luminous threads, forming faint helixes visible even through amateur telescopes. One astrophotographer in Japan captured a long exposure shot that went viral online. A brilliant spiral of blue-white plasma coiling around the comet's body like a serpent made of light. Scientists dismissed it at first as optical illusion until the magnetometer data confirmed the shape matched the real magnetic topology. 3I Atlas wasn't simply passing through the solar wind, it was reshaping it, deflecting it, wrapping it into ordered forms. When the solar storm of October 29 struck a wall of plasma travelling at 2,000 kilometers per second, researchers expected the comet's magnetic field to collapse instantly. Instead, the field's amplitude doubled. For nearly 20 minutes, 3I Atlas withstood a blast of charged particles that would have vaporized any unprotected probe. The data showed a standing wave pattern forming at the boundary of its magnetic envelope, a compression shock, steady and stable. It was behaving exactly like a planetary magnetosphere. Either this thing has a core dynamo, said Dr. Kim, or we've just discovered a completely new form of plasma physics. Her next words, however, never made it into the official transcript, or it's shielding itself. By November, the comet's field had become so pronounced that even amateur radio operators could detect interference when it passed behind the sundial. Shortwave signals dipped in sync with the comet's orbital position, like a ghost echo traveling through space. ESA's solar orbiter sent back polarized light measurements suggesting that dust grains in the coma were aligning themselves magnetically, not randomly, but radially, as though following field lines outward from the core. The effect was eerily similar to iron filings around a magnet. For some, the idea of an artificial magnetic envelope began to creep into discussion, not in official journals, but in private messages, encrypted group chats, and off-record meetings. The concept was unscientific, even heretical, but the numbers wouldn't stop whispering. If the field was self-generated, it required organization, an internal mechanism, not chaos. Something beneath the crust must be orchestrating these oscillations. The key clue came when radio astronomers plotted the 3.8-hour magnetic cycle over a longer period. After 4 days, the waveform resolved into a secondary pattern, a slow modulation resembling a beat frequency, the kind produced when two oscillators interact. That meant that the field wasn't singular, it was dual. Two interacting sources, alternating, counter-rotating, and merging. The realization left even the most skeptical physicists staring in silence. A natural comet might have complex plasma behavior, yes, but dual synchronized magnetic oscillators, that cross the line between physics and intent. When news of the magnetic shadow reached the public, it was immediately dismissed as conspiracy. The idea of a comet generating its own electromagnetic shield sounded like science fiction. But to those monitoring the data, fiction had already fallen behind. Somewhere deep within 3I Atlas, currents were moving, currents that pulsed, aligned, and adapted. The magnetic envelope grew not weaker, but more refined, its boundary tracing intricate geometries invisible to the eye, yet unmistakable in the math. Whatever slept inside the comet was no longer dormant, and in the charged silence of space, where solar wind and starlight met, 3I Atlas had begun to hum. It started with a whisper on a late shift at the Cerro Paranal Observatory in Chile. Dr. Livia Moreno, a planetary spectroscopist, was rechecking 3I Atlas's data for the 4th time that week, not because she doubted the results, but because she couldn't believe them. The comet's spectral fingerprint was mutating faster than any model could account for. Emission lines appeared, vanished, and reappeared again with eerie precision, as if orchestrated. She was comparing the latest data from the Very Large Telescope against archived interstellar spectra, hoping to find a clue to the comet's origins. That's when she saw a cluster of faint isotopic ratios that didn't belong to our neighborhood at all. It was subtle. A nickel isotope ratio skewed 2.8% higher than any solar system object. A trace of deuterated cyanide, DCN, so extreme it bordered on the anomalous. And buried within those lines was a pattern she recognized not from comets, not from planets, but from a neutron star remnant. She cross-matched it against an old database of supernova ejector signatures collected by the ALMA array. There, among the ashes of an ancient binary system catalogued as NS1447E, 700 light-years away, she found a near-perfect overlap. The match, 94%. For context, that's higher than the isotopic match between Earth and its own moon. Her heart froze. She ran the comparison again. Same result. 3I Atlas carried a chemical fingerprint indistinguishable from material forged in a system that had died long before the sun was born. The discovery spread through the astronomy community in hours. Private group chats turned into emergency conferences. The first question was obvious. How could a comet from a neutron star system survive? Neutron stars are cosmic graveyards, the collapsed cores of massive suns, their surroundings sterilized by radiation. Nothing as fragile as a comet should exist within light years of one, yet the chemistry didn't lie. The signature wasn't in a single element, it was everywhere. Oxygen 1:8 ratios off the chart, nitrogen 1:5, enrichment identical to ejector models from heavy metal synthesis zones. Even trace isotopes of ruthenium and palladium, the kind that only form in rapid neutron capture or R-process nuclear synthesis, match the profile of NS1447E's debris disk. It was as if 3I Atlas had been born in the fire of a dying star. Dr. Moreno published a preliminary report to the International Astronomical Union's internal server under the cautious title Isotopic Overlap Between Comet 3I Atlas and Neutron Star Ejector Candidates. Within 24 hours, the file had been downloaded thousands of times. The first public response came from Dr. Thomas Rhee at Caltech. If verified, this would mean 3I Atlas is not just interstellar, it's inter-epochal. We're looking at matter older than the solar system itself. The phrase interstellar signature was born. To understand why this was so shocking, you have to grasp what isotopic fingerprinting means. Every stellar nursery has its own chemical accent, a ratio of isotopes shaped by the types of supernovae and cosmic ray bombardments that seeded it. Our solar system, for example, carries a specific ratio of carbon 1,2 to carbon 1,3, oxygen 1,6 to oxygen 1,8, and so on. When scientists measure those ratios in meteorites or interstellar dust, they can often trace their origins to particular types of stars. It's like stellar forensics. What 3I Atlas presented was impossible for two reasons. First, its isotopic ratios didn't just differ slightly, they were systematically offset in the direction predicted for remnants of neutron star ejector. Second, the ratio shifts were internally consistent, as if the entire body had formed from a single homogeneous reservoir, not a mix of materials from different stars, but the leftovers of one catastrophic event. This was more than a mystery, it was a message written in chemistry. Some astrophysicists suggested that perhaps 3I Atlas condensed in a peripheral region of a neutron star's accretion disk, where temperatures dropped just enough for volatiles to freeze again after the explosion. Others floated the idea that it was born in a secondary disk around a binary companion that had survived the collapse. But one model stood out, a scenario proposed by Dr. Jiawen Xu, a theorist at Peking University. She argued that the comet's unique isotopic mix suggested capture and reformation, According to her model, material blasted out from the supernova of NS 1447e could have coalesced billions of years later in a quiet, stable region of interstellar space. Over time, gravitational eddies, perhaps from passing stars, could have drawn that debris into clumps, forming new icy bodies from the ashes of the old system. If true, 3I Atlas wasn't a survivor. It was a reincarnation. But something didn't fit. The abundance of volatile compounds, particularly hydrogen, cyanide and carbon monoxide, suggested formation in a cold, dense region shielded from radiation. Yet, neutron star ejecta would be saturated with heavy elements and stripped of volatiles entirely. That paradox kept scientists awake. One possibility, the comet has spent eons traveling through interstellar molecular clouds, absorbing gases like a sponge. Over millions of years, those gases might have frozen into its crust, creating a layered chemistry, ancient core, young skin. But the deeper readings complicated even that theory. The volatiles weren't surface contamination, they were internal. Trapped pockets of cyanide-rich ice that had been sealed since its formation. And that cyanide, the same compound found earlier in strange ratios, bore isotopic anomalies identical to NS 1447e, meaning the volatile ices themselves were ancient, not absorbed later, but formed at the same time as the core. That meant only one thing. Something about that neutron star system had allowed comets to form. The implications were staggering. If 3I Atlas was representative of a whole class of such objects, then life-forming chemistry could exist even in the aftermath of stellar death. Cyanide, water, organic chains, all built from neutron star debris. It blurred the line between creation and destruction. Dr. Moreno described it simply, it's like finding a flower blooming in a crater. As the data poured in, the 94% isotopic match became the most discussed number in astronomy. Skeptics tried to poke holes in it, suggesting calibration errors, background contamination, even cosmic ray interference, but every reanalysis only tightened the correlation. At the same time, the comet's spectral lines began to shift again. Subtle changes in the nickel emissions hinted at a new isotope appearing, nickel 60, a decay product of iron 60, the same radioactive isotope forged in supernovae. It shouldn't still exist after billions of years, yet it did, faint but real, which led to the most unsettling conclusion yet. Either 3I Atlas was far younger than anyone thought, perhaps formed in the recent remains of NS 1447e, or there was some unknown mechanism preserving its isotopes far beyond their expected decay limits. Both options were terrifying, because if the comet really was young, then its journey here had to be deliberate, a targeted trajectory across interstellar space, not a random drift. And if it was ancient, preserved against entropy for eons, then it was made of something we still don't understand. When Dr. Moreno presented her findings at a private symposium in Geneva, she ended with a single slide. A composite spectrum, 3I Atlas on one side, NS 1447e on the other, two sets of coloured lines perfectly overlapping, and beneath them a question written in quiet white text. What if the universe recycles its messengers? The room fell silent, because somewhere, 700 light years away, the ashes of a long dead star still glowed faintly in radio wavelengths, and now, across billions of kilometers of space, one small icy fragment was carrying its memory back to us. 3I Atlas had a home, and it wasn't ours. The first report didn't come from NASA or the European Space Agency. It came from a backyard in Adelaide, Australia. A citizen radio astronomer named Dean Kelleher had been scanning the southern sky as part of a long-running project to map faint radio transients. It was a clear night, October 30th, and the Sun's most recent coronal mass ejection had just rippled across the magnetosphere, flooding the ionosphere with static. Dean was about to shut down his array when his software caught something faint, a set of repeating pulses. Weak, fuzzy, but distinct enough that his algorithm tagged them as non-random. He zoomed in. The source region? Just a few degrees off the position of 3I Atlas. At first, he assumed it was spillover from one of the known odd radio circles, those vast, diffuse rings of radio emission first discovered in 2019, still unexplained, still controversial. But as he filtered the signal, something unusual emerged. A pattern. 3 pulses, a pause, then 5, then a long silence, then again 3, 5. Sandawu, Sandawu. He joked to his online group chat, "Maybe it's Morse code for I see you." They laughed until 2 other observers, one in New Zealand, one in Chile, confirmed the same thing. Within 48 hours, the amateur astronomy community was ablaze. Dozens of independent radio setups across the globe detected identical pulses, repeating roughly every 47 minutes. Weak, but synchronized. The apparent source region tracked precisely with the trajectory of 3I Atlas as it drifted sunward. Professional observatories took notice. The Meerkat Array in South Africa pointed its dishes toward the coordinates. Its high-resolution interferometry confirmed that the emissions weren't from deep space quasars or local satellites. They were local to the solar system and moving. The spectral energy distribution matched no known radio source. Too narrow for a flare star, too structured for cosmic background interference, and too regular for natural noise. The discovery reignited interest in the odd radio circles, or ORCs, those ghostly bubble-like radio emissions hovering around distant galaxies, thought to be remnants of ancient energetic events. Some now wondered, were those circles too the byproducts of massive interstellar objects passing through magnetic fields, or could 3I Atlas itself be generating a localized analogue of the same phenomenon? Because as the comet brightened visually, radio telescopes began to detect something uncanny, a faint spherical halo of low-frequency emission expanding around it, a radio circle. At Jodrell Bank Observatory, analysts filtered weeks of background data and found something they hadn't expected. The circles were evolving. The faint outer shell of emission around 3I Atlas wasn't random noise. It grew, contracted, and rotated. And at its center, the nucleus of the comet, a rhythmic pulse persisted, unchanged. When the team plotted its timing sequence over the comet's orbital motion, they found a pattern. The interval between bursts shortened every time 3I Atlas crossed a region of increased solar wind density. It was reacting, adapting, like a living circuit responding to current. One paper called it plasma resonant interference. Another called it structured feedback. But the amateurs online had another name for it, the beacon. The beacon wasn't strong just above the noise floor, but it was eerily consistent. And it didn't drift with Doppler shifts the way natural sources should. Instead, it stabilized itself. Each time the comet moved, the pulse frequency compensated perfectly to maintain coherence. That suggested control, or at least regulation. Some astrophysicists proposed that the pulses might result from interference patterns between the comet's magnetic envelope and incoming solar plasma. Imagine ripples colliding in a pond, creating stable wave fronts. If 3I Atlas's field had internal symmetry, as suspected from previous magnetometer readings, those collisions might naturally generate repeating radio bursts. but the math didn't cooperate. Simulations showed that such patterns should disperse in minutes. The Atlas pulsars had persisted for weeks. Then, on November 3rd, the ASCAP array in Western Australia detected a second halo, this time not centered on the comet, but 0.12 degrees offset, like a twin ghost. It expanded outward at the speed of light, faded, then reappeared. And when overlaid on the comet's magnetic field data, it formed an interference pattern, almost like a moire fringe, concentric waves folding through each other, their intersections glowing brighter in the radio band. That was when one researcher noticed a chilling coincidence. The phase interval between the Atlas pulses and the interference fringes matched the 3.8-hour magnetic oscillation first detected weeks earlier, meaning the comet's magnetic heartbeat was driving the radio circles. The next question was inevitable. Was this natural? The official consensus leaned toward yes, at least publicly. Plasma interactions, particle resonance, background refraction, the usual suspects. But privately, researchers exchanged late-night messages filled with unease, because some of the pulse intervals weren't just repeating, they were numerical. When converted from frequency space into ratios, the intervals fell into harmonic proportions, 3:2, 4:3, 5:4, the same ratios that define musical consonants. In essence, the comet was singing in tune. Even more disturbing, when mapped over time, the intervals formed sequences that resembled encoded modulation bursts that weren't random noise, but contained internal structure. It wasn't a message. Not yet, but it was order. Meanwhile, the odd radio circles, elsewhere in the sky, those far-off halos of radio light around distant galaxies, began to draw new attention. Several teams noticed that some ORCs exhibited faint periodicities, subtle ripples in their brightness curves, echoing the same harmonic ratios found in Atlas's emissions. Coincidence? Pattern recognition bias? Perhaps. But others wondered, what if ORCs weren't relics of explosions at all, but the long decayed signatures of objects like 3 I-Atlas cosmic wanderers shedding radio halos as they pass through plasma fields across epochs? If so, then we were seeing echoes of a galactic network, not communications, but footprints, frozen interference left behind by travelers long gone. As November deepened, the pulse rate increased again. 47 minutes became 44, then 41, and then, abruptly, silence. For 3 days, every array on Earth recorded nothing. The beacon had vanished. Theories exploded. The solar storm disrupted it. The comet's field collapsed. Instrumentation error. But on the 4th day, a new signal appeared, stronger, shifted, lower in frequency, and now mirrored 2, pulse, pause, 2, pause. The same pattern seen before, but now split into stereo. The comet wasn't gone. It had changed channels. When the data was filtered and visualized as a spectrogram, analysts noticed a faint structure in the noise floor, circular interference ripples radiating outward from the pulse bands. The pattern looked identical to the odd radio circles that had inspired the comparison weeks earlier, only this time the source wasn't billions of light years away, it was inside our own system. For the first time, we were watching an ORC form in real time. And it wasn't around a dying galaxy. It was around something alive, or at least behaving like it. At the end of the week, Dr. Moreno, the same scientist who discovered the interstellar isotopic match, summarized it best in a midnight interview. If these radio circles are interference, then interference with what? The background, the sun, or something projecting from within? A voice faltered. Whatever it is, it's not just reflecting light anymore, it's reflecting intent. The host sat in silence for a long moment, then quietly said, "So you're saying the comet might be talking?" She didn't answer, because somewhere above the radio noise, faint but steady, 3I Atlas pulsed once more. And this time, every dish on Earth was listening. It began, as these things often do, with coincidence, or what seemed like coincidence. By late October, the orbital models were clear. Mercury, Ceres, the Sun, and 3I Atlas would line up in a narrow corridor of celestial geometry, not seen in over 6 centuries. It was an elegant, fragile moment, a fleeting thread connecting the smallest planet, the largest asteroid, our star, and an interstellar wanderer that didn't belong here at all. Astronomers called it the October alignment. Astrologers called it something else, the messenger's crossing. Because in ancient symbolism, Mercury was the messenger between worlds, the bridge between mortal and divine, chaos and order. And now, in 2025, Mercury would once again stand in a line with something whispering through the dark. From Earth, the night sky seemed ordinary. No one looking up could have sensed that geometry was tightening in the void, or that deep in space, forces were about to converge on one point. At the European Southern Observatory, Dr. Moreno and her team had set their instruments to automatic tracking. They didn't expect anything unusual. The comet had quieted for days after its last radio flare. The data looked stable. Then, at 3:41 UTC, as Mercury slipped into perfect solar longitude alignment, the readings from multiple observatories spiked simultaneously. Dry Atlas had brightened again, and this time dramatically. The initial estimates put its apparent magnitude near plus 4.3, visible even to amateur scopes despite its vast distance. Within hours, the value jumped to plus 3.7, the kind of brightness surge that would take most comets weeks to reach, not minutes. But the timing was impossible to ignore. The flare began precisely when the alignment completed, not a minute before or after. Solar physicists were quick to caution against cosmic coincidences. Alignments happen constantly, they said. Gravity doesn't care about mythology. But even the skeptics couldn't ignore what happened next. The SOHO spacecraft recorded an abrupt increase in solar wind flux, a small but distinct pulse of high-energy particles directed exactly along the alignment corridor. Not an eruption, not a flare, just a focused current, as though the sun itself had exhaled toward that line. And 3I Atlas answered. Its coma expanded violently, ejecting plumes of dust and gas visible even in low-resolution ground images. Spectrometers detected a surge in hydroxyl emission, a chemical fingerprint of freshly liberated water, but with new lines never seen before. Faint ultraviolet harmonics at 283 nanometers, just shy of ozone's spectral band. The comet wasn't just reflecting sunlight, it was reacting to it. Across the world, live feeds lit up. Amateur astronomers streamed the event on YouTube and TikTok, their comment sections filling with disbelief. Viewers reported seeing a ghost tail, a faint secondary plume curving backward along the Sun-Mercury axis. It was almost poetic. The messenger, the asteroid queen, the sun, and the alien wanderer, all bound in a line, the heavens lighting up in synchrony. But inside the control rooms, poetry turned to panic, because every instrument, magnetometers, photometers, radio receivers, recorded synchronous resonance. The magnetic pulse that had haunted Atlas for weeks flared in amplitude. The radio circles around it grew brighter, compressing in frequency as though harmonizing with solar oscillations. For 12 minutes, the comet's pulse rate shifted from 44 minutes to 41, then to a perfect harmonic of the sun's own 5-minute acoustic mode. It was as if 3I Atlas had locked onto the sun's heartbeat. Meanwhile, Astrologers and mythologists took to social media with uncanny timing. They quoted passages about Mercury guiding souls between realms, Ceres mourning the loss of her child to the underworld, and Atlas the Titan condemned to carry the heavens. The symbolism was too rich, too aligned, too unnerving. But while the internet argued over omens and orbital mechanics, something else was happening quietly, data that wouldn't surface until days later. At the height of the alignment, Solar Orbiter recorded faint, transient radio echoes bouncing between the Sun and the comet. Not reflections, resonances. Short bursts of energy mirroring each other across space, like a ping between two active nodes. That should have been impossible. Echoes require surfaces, conductive, structured ones. Comets are porous rubble, not mirrors. Yet the signal existed. Measurable, repeatable. One astrophysicist, speaking off the record, described it like this: "It's as if the sun tapped the glass and Atlas tapped back." When the flare finally subsided, the comet's coma had grown nearly 70% in volume. Its tail stretched millions of kilometers further, shimmering with filaments that twisted like magnetic ropes. The visible spectrum shifted slightly blueward, hinting at higher ionization, meaning its activity had reached plasma temperatures far beyond what sunlight alone could produce. And yet, after all that fury, the comet's trajectory barely changed. No measurable deviation, no new acceleration. It was as if all that energy had come from within. For the first time, some began to whisper the unthinkable. Maybe the flare wasn't triggered by solar heat or particle impact. Maybe it was a response, a resonance event between the sun's field and whatever hidden engine stirred inside the comet. The media called it the Mercury flash. Astrophysicists called it the alignment surge. And fringe theorists called it the awakening 2. But no matter the name, the event left a permanent mark on the data. Infrared telescopes later confirmed that during those 12 minutes, Atlas's surface temperature had increased by nearly 20 Kelvin, yet without any corresponding spike in solar flux. The heat had come from nowhere, or perhaps from somewhere beneath. Cultural scholars couldn't resist connecting the mythic dots. Mercury the messenger in perfect alignment during the moment a cosmic traveler spoke, Ceres symbol of rebirth and harvest, flanking the same line. The sun giver of life. Even those who rejected astrology found the symbolism unsettling, because in that alignment, meaning seemed to bleed through mathematics, as if the universe itself had chosen a language we could both understand. As the skies returned to normal, the comet's light curve slowly faded, but it didn't return to baseline. It stayed brighter permanently. Spectra reveals subtle chemical shifts too, hydrogen cyanide lines strengthening, oxygen ratios changing. Something had altered inside it, perhaps structurally, perhaps energetically. But for now, no one knew why. All they knew was this: during the alignment of Mercury, Ceres, and the Sun, an interstellar wanderer had pulsed in rhythm with our star, answered its resonance, and burned with a light no one could explain. The ancient sky watchers would have called it an omen. Today, we call it data. But deep down, maybe we still feel both. And if the heavens really are a language, then on that night, the message was simple. Something hears us. For weeks, 3i Atlas had behaved like a living paradox, flaring, cooling, brightening again. But after the Mercury alignment, it began to pulse. At first, no one noticed. The increase in brightness was gradual, and the data feed from most observatories was still being calibrated. But then came the timestamp anomalies, tiny, repeating irregularities in photometric readings, all spaced exactly 2.7 seconds apart. At Cerro Paranal, Dr. Moreno leaned over the console. "Check that timing drift," she said to her assistant. "Could be clock jitter from the mount controller." They resynced. The pulses stayed. Every 2.7 seconds, a fractional rise in luminosity, barely 1/10%. almost invisible but unmistakably periodic. At first, they blamed interference, then atmospheric distortion, then instrument error, but the same signature appeared everywhere, from Chile to Hawaii, from South Africa to the Canary Islands. Even the JWST, hundreds of thousands of kilometers away, saw it. The light curve was clean. Sharp rise, steady fall, repeat. Perfect. No phase noise, no decay. And it was coming from the comet itself. By dawn, the astronomy networks were buzzing. Observatories traded data files, overlaid timestamps, and found near-perfect synchronization within milliseconds. That shouldn't be possible. Light reflecting from a tumbling body, especially a comet with an irregular surface, should produce chaotic flickers. A few spikes, yes, but nothing rhythmic. Nothing like a metronome counting in the dark. But Atlas was flashing every 2.7 seconds. Exactly. Dr. Yuki Takahara at the National Astronomical Observatory of Japan ran a spectral decomposition on the pulses. The results deepened the mystery. The pulse peaks showed spectral flattening, as if the light wasn't purely reflective but modulated. The ratio of visible to infrared emission shifted slightly with each burst, almost like a signal encoded in color temperature. Natural reflections don't do that, Takahara murmured, not unless the surface changes phase every cycle. But the comet was millions of kilometers away. What mechanism could alter its albedo that fast? The answer, of course, was none. Meanwhile, at NASA's Deep Space Network in Goldstone, engineers began combing through radar returns from their last ranging session. To their astonishment, the echoes had contained faint oscillations at 2.7 second intervals. That number, again, too long for a mechanical spin, too short for a thermal cycle. Not tied to the comet's rotation, either its day lasted over 10 hours. So what was it? The only analog anyone could think of was a beacon. When the analysis team plotted the pulse intervals against universal time, something else emerged. The peaks were slightly phase shifted with respect to Earth's rotation, as though compensating for distance. Someone joked that the comet was tracking us. No one laughed. By the following night, the 2.7 second rhythm had strengthened. The light curve became more distinct, its amplitude increasing with every observation window. When plotted on a logarithmic scale, the pattern revealed something terrifyingly elegant, a rising exponential envelope, as though the pulse train were amplifying itself over time. At the Harvard-Smithsonian Center for Astrophysics, a postdoc named Adrian Cole decided to dig deeper. He extracted the light intensity values from the first 48 hours of the pulse event and ran a fast Fourier transform. The result was not noise. The FFT produced a perfect harmonic ladder frequency, multiples at 2.7, 1.35, and 0.9 seconds. Ratios that corresponded eerily to common radio frequencies in hertz. 370 MHz, 740 MHz, 1.1 hertzes. Cole froze. "Those are transmission harmonics," he whispered. It was as if the comet's light was encoding carrier signals, visible radio. The team published a private circular to the IAU. Within hours, leaks hit the web. "Comet flashing at regular interval," one headline read. "Alien beacon or instrument error." Another scoffed. The world turned its eyes upward again. Live streams exploded. Amateur astronomers with backyard telescopes confirmed the pulse themselves. It was faint, but real. Every few seconds, the distant wanderer blinked, not irregularly, not randomly, but deliberately, like a heartbeat or a countdown. At the Parkes Observatory in Australia, radio dishes locked onto the comet's position. They detected faint electromagnetic sidebands, synchronized exactly with the light pulse's sub-microtesla fluctuations at the same 2.7 second rhythm. It's not just light. one operator said. It's field activity. Simultaneous magnetometer data from solar orbiter showed micro variations in the interplanetary magnetic field, also periodic. It was as though the comet's new magnetic sheath, first observed weeks before, was now pulsing in sync with its light output. Theories collided. One camp claimed plasma oscillation, that Atlas had developed a natural resonance between its internal conductivity and the solar wind's dynamic pressure, like a giant capacitor charging and discharging. Another argued that this was some form of electrochemical feedback, perhaps involving volatile ionization and cyclic outgassing. But none of these models could explain the precision. Nature doesn't pulse with atomic regularity, and certainly not at human timescales. Every 2.7 seconds, not 2.6, not 2.8, exactly. Somewhere in the chaos, an anonymous data analyst noticed something chilling. When plotted against time, the pulse intervals weren't entirely constant. There was a subtle modulation, a slow oscillation in frequency. When converted to audio, the pattern formed a beat tone, rhythm, rising and falling like breath. The same breathing signature first observed months ago when Atlas exhaled 40 kilograms of water per second into the void. The comet was breathing again, only now it was doing so in light. As night fell over the Western Hemisphere, observatories aligned their optics for continuous tracking. The comet, far beyond Mars's orbit, was still brightening. Dr. Moreno stared at the live feed, watching the tiny blinking point on her monitor. 2.7 seconds. 2.7 seconds. 2.7 seconds. She whispered what no scientist ever wants to say out loud. It's not random. In the following hours, cross-correlation of optical and radio data revealed a final, impossible detail. Each pulse had a delayed echo, a reflection of itself arriving a fraction of a second later than the primary burst. But the echo wasn't from Earth. Triangulation placed its origin behind the comet from somewhere in its own tail, as if something back there was answering. For the first time, humanity stared into the night and saw not just a reflection, but a conversation, a rhythmic whisper traveling across the darkness, encoded in the shimmer of dust and ice. Coincidence, they said. Interference. Solar wind modulation. But deep down, the silence between those flashes spoke louder than any denial could, because in that silence, between each heartbeat of light, the question had already taken root. Ancient, terrifying, beautiful. What if it's not reflecting us at all? By the end of the third week, 3I Atlas began to fade. The furious brightness that had once cut across the deep sky started to soften, its magnitude slipping back toward the numbers astronomers had expected months before. But the pulse, the impossible 2.7 second rhythm, refused to die. Even as the comet dimmed, even as its coma thinned and the water vapor halo dissipated into the solar wind, the light pattern stayed weaker but precise, a whisper in photons. And hidden inside that whisper was something none of them were ready for. At the European Southern Observatory, a special task group formed overnight. Their goal, to decode whatever information the comet's flickering tail might contain. They called it Project Echo. Data poured in from telescopes around the world. Dozens of terabytes of photometric logs. Every frame, every pulse, every micro variation in luminosity. When the team compressed the signal into a single time series, they noticed something strange, a faint modulation layered beneath the 2.7 second beat. Tiny variations in brightness, amplitude, some strong, some faint, almost like a binary code. On, off, bright, dim, E, ling, No one said it out loud, but everyone was thinking the same thing. They ran the sequence through statistical noise filters, expecting randomness. Instead, they got structure. The spacing of the amplitude peaks matched a prime sequence. 2, 3, 5, 7, 11, 13, repeating, cycling. Prime numbers, the mathematical language of the universe. The discovery hit the community like a silent explosion. Astrophysicists argued for days, was it real data or an artifact of sampling? Could cosmic rays or electronic noise fake prime intervals? But across every dataset, Chile, Hawaii, Japan, Australia, the same pattern persisted. The same cadence, the same mathematical fingerprint. If this was a coincidence, it was the most precise one the universe had ever staged. As the comet drifted farther from the sun, its tail began to shimmer faintly in ultraviolet. Swift's sensors picked up weak oxygen emissions, but with strange periodic dimming synchronized with the pulses. It was as if the gas itself was participating in the rhythm, scattering light in coded waves. At the same time, Solar Orbiter detected faint oscillations in the interplanetary magnetic field, now echoing those same prime intervals. The comet wasn't just flashing anymore, it was communicating through its environment. Every ion, every dust grain, every photon, vibrating in perfect sync. Dr. Yuki Takahara stared at the light curve on her screen. "It's responding," she said softly. No one in the lab answered. They were too afraid to. Responding to what? To the solar storm? To the sun itself? To us? NASA's Goddard team ran a long baseline correlation comparing the comet's pulses to radio emissions from the sun's recent coronal mass ejections. That's when the impossible connection appeared. Each time a CME erupted, 3 I-Atlas flared exactly 499 seconds later, the time it would take for light to travel the distance between them. Not before, not random, after, precisely, as though the comet was replying to the Sunday. Every solar burst was followed by an answering flicker. Every surge of light was mirrored by another across the void. Call and response, star and wanderer, like 2 instruments across the cosmic stage, trading notes in silence. And then, just as suddenly as it began, the pulse began to slow. 2.7 seconds became 2.8, then 3, then 3.4. The comet's heartbeat was fading. But within that slowing rhythm, a final message began to take shape. Not binary, not code, but harmonic structure. When the amplitude was converted to audio, it formed a sequence of tones, frequencies corresponding almost perfectly to the spectral lines of hydrogen, oxygen, and carbon. The building blocks of life. The comet's dying pulse was singing the molecular song of everything alive. The data reached its last breath on the 12th of November 2025. At 3:41 UTC, 3 I-Atlas emitted one final, drawn-out pulse, a single luminous swell that lasted nearly 20 seconds. It glowed bright enough to outshine every star in Pisces for that fleeting moment. And then, darkness, no more pulses, no reflection, just the silent wake of dust trailing a vanishing world. In the weeks that followed, scientists combed through every byte of telemetry, trying to make sense of it all. There were no definitive answers, only theories. Some said the comet's strange chemistry, the nickel without iron, the cyanide, the isotopic oddities, had created an exotic reaction deep within its crust, a kind of natural plasma oscillator that mimicked order out of chaos. Others insisted it was a coincidence, the mind's instinct to find pattern where none exists. But a few refused to accept that. Dr. Moreno, now leading Project Echo, wrote the final line of the mission report. "We are not observing a reaction, we are witnessing a reply. Months later, when the comet slipped beyond the range of every telescope on Earth, amateur radio operators began reporting faint fluctuations at 370 MHz, the same harmonic that once defined its light pulses. Weak, broken, almost gone, but still there, like an echo that refuses to fade. And somewhere beyond the frost line, between the sun's diminishing reach and the cold inheritance of the interstellar dark, 3I Atlas continued its journey, silent, frozen, and yet somehow listening. Maybe it was never just reacting to sunlight or magnetic pressure. Maybe it had carried that rhythm with it all along, the memory of a system long dead, a song encoded in ice, waiting billions of years for another star to answer. And when it finally passed through ours, it heard the sun's voice and sang back. A brief conversation across cosmic ages, two travelers meeting for the first and only time. When the last pulse faded, humanity was left with the most haunting realization of all. Maybe comets don't just seed life. Maybe they remember it. Maybe, across the endless dark, they carry the echo of the light that once made them. And for a brief moment in 2025, the echo remembered us.